What if the clock on your wall isn't telling the same story as a clock on a mountaintop, or on a satellite, or beside a black hole, and yet all of them are somehow right? What if time itself isn't a single river flowing smoothly and evenly everywhere, but a network of currents that speed up and slow down depending on where you are and how you move? Tonight, we're going to sit with a quietly unsettling idea, that your seconds, minutes, and hours are not as universal as they feel, and that the universe keeps more than one kind of time at once. Welcome back, traveler. Tonight we drift through science. You're probably lying somewhere familiar, maybe in a dim bedroom, phone or laptop glowing softly, the rest of the world already fading into background noise. As you settle in, if this calm kind of science helps you unwind you can gently tap like or subscribe so more nights feel like this. And if you feel like sharing later, you can always leave a comment with where you're listening from and what time your clock says in your corner of the planet. Maybe you pressed play because your mind wouldn't slow down. Thoughts about tomorrow keep looping. Worries stack on top of each other, and even simple tasks start to feel heavier than they should. It's okay to be here like that. It's okay to be tired, restless, or a little overwhelmed. You don't have to catch every idea or memorize every term. It's perfectly fine if your attention wanders, if some explanations blur together, or if you drift off halfway through. This isn't an exam. You're allowed to just listen and let the story move around you. Tonight we'll walk through the strange ways the universe treats time, how gravity can make it run slower near massive objects, how motion can stretch and compress the duration between events, how GPS satellites quietly correct for these effects so your maps don't get lost. We'll drift between cosmic scenes, the edges of black holes, fast-moving spacecraft, distant galaxies, and the very human places where people measured, compared, argued, and finally accepted that time is not absolute. You'll meet laboratories, clocks on mountains, and scientists puzzling over nanoseconds that refuse to match. As we go, you won't need to solve equations or follow every detail. We'll move slowly, circling back, turning hard ideas into images you can simply picture and then let go of. Think of this as a long, gentle walk through a landscape where time itself has hills and valleys. You can dim the screen a little, adjust your pillow, feel the weight of your body sinking into whatever is holding you up. If you'd like, you can close your eyes and just follow the voice. The journey is just beginning, and you're safe to rest while it unfolds. You might imagine yourself standing somewhere familiar, on a quiet street at night, the air cool against your skin, the world feeling still. In that familiar environment, it's easy to believe time moves uniformly, that each second is identical everywhere. But if you could lift gently away from your surroundings, as if rising like mist above the rooftops, you'd discover the truth. Time begins to stretch and relax long before you ever leave Earth. Even here, it's already disagreeing with itself. High above the clouds, time moves slightly faster. Down near the ocean, slightly slower. The difference is tiny, almost invisible, but measurable with clocks precise enough to catch a change of billionths of a second. Gravity is the reason. The stronger the gravitational field, the more time lags. Your heartbeat doesn't feel it. Your routines don't register it. But the fabric of space-time does, and it keeps its own quiet accounting whether you notice or not. Imagine placing two identical clocks, one at sea level and one on a mountaintop. They start perfectly synchronized. Days pass, weeks. When you bring them back together, the alpine clock is ahead, not malfunctioning, not drifting, simply living in a region where gravity pulls a little less strongly. Time itself flowed more freely there. That tiny difference is the same effect satellites must constantly correct for SAC or GPS systems would accumulate errors of kilometers each day. Think of the mountaintop clock as breathing easier. The weight of Earth's mass presses less heavily on it, so its ticks stretch very slightly. In physics terms, gravitational time dilation shifts the rate at which processes unfold. Chemical reactions, vibration cycles in atoms, even thought itself. This isn't metaphor, it's measurement. Every physical system carries the imprint of the gravitational environment it occupies. The first people to test this weren't imagining cosmic extremes. They were climbing towers, hauling equipment up elevators, setting clocks on balconies of university buildings. Their experiments didn't involve black holes or warp drives, just persistence and instruments capable of comparing frequencies with absurd precision. In small offices with fluorescent lights, researchers watched numbers diverge that were supposed to stay equal, realizing something profound was hiding in the decimals. You can picture them leaning over monitors, coffee cooling beside stacks of printouts, trying to understand why two clocks separated by a few floors refused to keep perfect rhythm. After enough confirmation, the discomfort turned into awe. The universe didn't care about their expectations. It cared about mass, curvature, and proximity to the center of Earth's gravity well. And time responded faithfully to these conditions, even in mundane settings. If you close your eyes now, you might imagine lying on the ground, feeling the pull of Earth beneath you, the downward tug, the firmness against your back. That sensation is gravity in the simplest sense. But beneath it is a deeper truth. Space-time curves around Earth, and everything from falling apples to drifting seconds is following the shape of that curvature. Time is not a universal metronome, it's a landscape. Landscape is a helpful image. Think of time flowing like a slow stream over uneven terrain. In valleys of strong gravity, the stream thickens and drags. On gentle slopes of weaker gravity, it glides more quickly. You, without realizing it, spend your entire life in one of those valleys. Someone living in a space station several hundred kilometers above Earth lives on a slightly higher slope where the current slides by faster. Data from the International Space Station confirms this. Astronauts age a tiny bit quicker during their missions, not enough to notice, but enough for atomic clocks to record. Meanwhile, because they're moving rapidly around Earth, special relativistic effects partially counteract that gain, slowing time relative to you. The combination creates a delicate balance, an ongoing negotiation between motion and gravity. Time never chooses one rule, it blends them. When you think of astronauts, you picture floating bodies, drifting tools, sunrises filmed through portholes. But behind those scenes is constant math. Mission planners track how much astronauts lose or gain in time relative to Earth. Even human biology aligns with relativity. Cell cycles and metabolic processes unfold according to the local rate of time's passage. No organism escapes the curve. It's enough to make you look differently at a simple elevation map. Peaks and valleys no longer represent just terrain, but gradients of time. A city sitting high in the Andes is aging slightly faster than one near the Dead Sea, and every person in those cities carries the effect unknowingly. The difference is imperceptible but persistent, a whisper in the background of every life. As you lie wherever you are, feeling gravity pull you toward your resting place, you're participating in this bending of time too. Your seconds are being tugged downward, held a little longer by Earth's mass. If you were lifted upward, by balloon, by aircraft, by imagination, you'd feel nothing, yet the deeper rules would shift. Time would begin gliding just a touch more easily. The universe doesn't wait for you to move fast or far. It adjusts time continuously, right where you are. This realization softens the idea of time as rigid. It becomes something more organic, shaped by surroundings, adapting to environment the way sound behaves differently in air and water. The clock on your wall feels authoritative, but its rhythm is only local truth. Somewhere else, on a hill, on a satellite beside a massive crater, another clock insists on a slightly different truth, and both are valid. Something gentle happens when you accept that. Your schedule, your deadlines, your sense of rushing, they all sit inside a framework that is itself flexible, responsive, uneven. You're not living inside a perfectly ticking universe. You're living inside a dynamic one, where even the flow of time carries the imprint of place. And once that idea sinks in, a more curious thought begins to tug at you from the edge of your awareness. If gravity can bend time here on Earth in such subtle ways, what happens to time near the densest, darkest places in the cosmos, where gravity becomes almost unimaginable? Far from Earth's gentle gravity, there are places where time is pushed into far more dramatic shapes. Picture a neutron star, the crushed core of an exploded massive star, a sphere only about 20 kilometers across but heavier than our Sun. Its gravity is so intense that a teaspoon of its material would outweigh mountains. Near its surface, space-time is warped steeply, like a cliffside in the landscape of time. A clock placed there would tick noticeably slower than one orbiting safely far away. Imagine hovering just above that neutron star in some impossible protective shell. The star's surface glows with X-rays, magnetic fields roar, and every movement feels like it happens under the weight of an invisible ocean. From your perspective, your heartbeat, your thoughts, your gestures all feel normal. But a distant observer watching your clock would see it crawl. Seconds for you would correspond to longer stretches of time for them. Time itself would be compressed in your vicinity. The ultimate example of this is a black hole. As you approach its event horizon, the point beyond which not even light can escape, gravitational time dilation becomes extreme. A clock carried downward slows compared with one held far away. In the limit of crossing the horizon, it appears to freeze from the perspective of a distant observer. You, falling in, would experience your own time normally, but the rest of the universe would seem to accelerate. Races of events unfolding while you plunge. This isn't just science fiction. The equations of general relativity predict it, and observations support the theory around real astrophysical black holes. When light climbs out of strong gravitational fields, its wavelength stretches. This gravitational redshift is another sign that time is running differently at different heights in the gravity well. In a sense, light carries the record of time's distortion, encoded in how its color shifts between emission and detection. To test these ideas closer to home, physicists conducted an experiment with atomic clocks flown on airplanes. Clocks on eastward and westward flights, as well as a reference clock on the ground, were compared before and after the journey. Their ticks diverged by tiny amounts, some slowed by speed, some adjusted by altitude, but all in agreement with Einstein's predictions. The Harfel-Keating experiment took relativity out of textbooks and strapped it into airline seats. Modern GPS is an ongoing demonstration. Satellites orbit high above Earth, where gravity is weaker, causing their onboard clocks to run faster than identical ones on the ground. But they also move quickly, which slows their clocks through special relativity. Engineers must correct for both effects. If they didn't, your navigation app would drift by several kilometers each day. Every time you see your location, dots snap accurately onto a map. You're watching time dilation quietly accounted for behind the scenes. Think about that for a moment. Your phone, a very human, everyday object, only works properly because we accept that time flows at different rates in different places and adjust our technology accordingly. The universe's strange treatment of time isn't a distant abstraction. It's baked into the system that guides you to a cafe or helps an ambulance reach an address. Even your most ordinary days, lean on the relativity of time. You can translate this into an image. Picture a network of tiny metronomes scattered from Earth's core to distant space, each ticking according to its own local space-time. Down deep, near dense masses, the beat lags. Higher up, the rhythm speeds. At great distances, the tempo reaches what we might call far-field normal. Relativity doesn't say one metronome is wrong. It says they're all telling the truth of where they are. There's something almost tender in that idea. Time isn't a tyrant imposing a single pace on everything. It's more like a musician adapting the tempo to the shape of the room, slowing in narrow passages, quickening in open halls. Gravity tells space-time how to curve, and curved space-time tells clocks how to tick. You and your heartbeat, your aging, are all quietly following this score, even if you never see the sheet music. Sometimes, the emotional weight of this can sneak up on you. If time moves differently depending on where you are, then there is no single, universal now that everything shares. Events that feel simultaneous to you are staggered for someone else. The present is no longer a razor-thin slice the whole universe passes through together. It's a patchwork of overlapping moments, stitched together by light signals that take time to travel. Yet your consciousness doesn't experience that complexity. For you, there is just this unfolding moment, one sensation after another, in a sequence your brain insists is continuous. You don't feel the nanosecond discrepancies, the altitude effects, the gravitational gradients. Those live in the realm of instruments and measurements. Your lived time is smoother, more cohesive, like a film played back at a constant speed even though individual frames were exposed under different conditions. If anything, this gap between physical time and experience time can be strangely calming. It reminds you that many of the things you worry about are built on an already approximate sense of duration. Minutes feel long or short depending on mood. Years can pass unnoticed until you find an old photo. Physics adds another layer. Even the supposedly objective seconds are context-dependent, molded by gravity and motion. Everything about time, from feeling to formula, is less rigid than it appears. You might take a slow breath and imagine that each inhale and exhale is happening on a gently sloping surface of space-time. The chair or bed beneath you, the floor, the foundations of your building, all sit together in the same gravity well, sharing roughly the same distortion. Far above you, satellites spin in orbits where time slides a bit faster. Far below, if you could descend toward Earth's core, time would drag more heavily. You inhabit one specific layer of this invisible stack. And having seen how gravity can bend time around planets, neutron stars and black holes, a new question naturally forms. What happens when motion joins the story? When you start moving very fast, or imagine yourself aboard a ship near light speed, carrying your own private rhythm of time through the universe. When you start to think about motion, time's flexibility deepens. Picture two spacecraft, identical in every way, floating side by side in the dark. Their clocks agree. Their crews share the same jokes over the radio. Their sense of now feels shared. Then one craft fires its engines and slips into a high-speed journey, looping far out and eventually returning to meet its twin. When they reunite, something subtle but real has happened. The traveling ship's clock shows less elapsed time. On board that fast craft, no one ever felt time slow down. Meals happened at normal intervals. Conversations unfolded naturally. People grew tired, slept, woke, and worked according to their own steady rhythm. The strange part only appears when they compare histories at the end. The traveler has aged less than the one who stayed behind. A gap opens between their experiences, like two paths that began together but didn't accumulate the same distance. This thought experiment, the so-called twin paradox, has become one of the most famous illustrations of special relativity. It's not paradoxical once acceleration and deceleration are accounted for, but it remains emotionally unsettling. Two lives that felt equally full in the moment turn out, born in the ledger of space-time, to have different lengths. Motion through space has quietly shaved time away from one twin compared with the other. Neither twin did anything wrong. They simply followed different routes through space-time. Evidence for this isn't limited to imagination. Particles called muons rain down on Earth from cosmic rays striking the upper atmosphere. At rest, muons decay so quickly that most should vanish long before reaching the ground. Yet detectors at the surface register far more of them than non-relativistic calculations predict. The explanation is that, from the muons' perspective, time is slowed by their high speed. Their internal clocks run so gently that they live long enough to reach you. Motion stretches their lifetimes. Accelerators such as CERN's Large Hadron Collider exploit the same effect. Particles are whipped around ring-shaped tunnels at speeds just shy of light. Their clocks dilated so dramatically that unstable species persist far longer than they would sitting still in a lab. Physicists count these extended lifetimes to confirm relativity's predictions. The very existence of modern particle physics depends on accepting that time is not absolute. It bends not only under gravity, but also under speed. Thinking about this can make your everyday motion feel oddly significant. When you walk, drive, or fly, you do experience an infinitesimal slowing of your time relative to someone standing still. The effect is far too tiny to matter in your lifetime, but it's there in principle, a measurable difference if your instruments were impossibly precise. Even on ordinary days, each path you take through the world is also a particular path through time. Speed alone doesn't tell the whole story, though. What matters is your entire history of motion. When you sped up, when you slowed, which route you traced through space-time compared with someone else. That's why the traveling twin is the younger one. Their world line bent and curved more. They turned engines on and off, changed direction, switched frames, while the stay-at-home twin followed a simpler, straighter path. Time accumulates differently along those two routes. In a way, this is like hiking across uneven terrain. Two people leave the same camp and regroup at a distant ridge. One takes a winding path over peaks and through valleys. The other follows a smooth, gently rising trail. When they meet, they've both arrived at the same coordinates. But the first hiker has traveled farther, with more climbs and descents. In relativity, the distance along a path is measured in time. The more contorted the route, the less proper time is accumulated. Your nervous system smooths all of this away. You feel time as a nearly uniform flow, regardless of how you move, because your body and brain adjust together. Every process, the ticking of neurons, the chemical reactions in your cells, slows or speeds in sync. You never stand outside yourself to compare. Only when you line up clocks that took different journeys or detect particles that lived too long does the difference emerge. Relativity hides in the comparisons, not in the moment-to-moment feeling. There's a gentle lesson tucked in here. The universe doesn't hand out identical durations just because two beings share a starting point. Paths matter. Choices matter. Trajectories through the world yield different amounts of lived time, even if the difference is microscopic on human scales. You might never notice a measurable gap, but the principle stands. How you move through your days shapes how much time those days contain, in more senses than one. On a quiet night, it can be comforting to think of yourself as moving relatively slowly, anchored to Earth's surface. You're not skimming near light speed around a black hole or circling the galaxy in some furious orbit. Your seconds are as full as they can be. your proper time as generous as the universe allows for such gentle motion, there is something richly ordinary about that. A kind of cosmic leisure. Physicists sometimes draw diagrams called space-time diagrams, with time running vertically and space horizontally. Your life becomes a line slanting upward, each point a moment where you occupy a specific place. A faster traveler tilts more, a stay-at-home observer climbs more directly. The geometry of these lines encodes all the time dilation we've been talking about. Somewhere on a whiteboard, your kind of path, quiet, earthbound, is scribbled as the reference, the standard against which others are compared. Looking at those diagrams, you might realize that where you are in the title of this journey isn't just a location in space, it's a position in this web of possible paths. Standing still, walking, flying, orbiting, free-falling near a compact star, each is a different way to thread yourself through the fabric. Time responds accordingly, lengthening or shortening its gifts along the way. The universe keeps impeccable track, even if you never see the ledger. Once motion joins gravity in shaping time, the world feels less like a synchronized orchestra and more like a vast improvisation, each instrument playing at a slightly different tempo depending on where it's seated and how it moves. Clocks, particles, people, stars, all are following rhythms set by their particular circumstances. There is no single universal beat that everyone marches to. There is only the local truth of each path. And knowing that, it's natural to start wondering about the biggest stage of all. How do these warped and stretched times fit into the vast structure of the universe, where clusters of galaxies move, space itself expands, and different observers can't even agree on what counts as now? You grow up with the sense that there is a single, shared now, a universal moment that everything passes through together. It feels obvious. If a lightning bolt strikes a tree outside while a glass falls in your kitchen, those events either happen at the same time or they don't. The idea that different observers could disagree about that sounds like a word game. And yet, once you let motion and light's finite speed into the picture, now begins to wobble. Imagine a long train gliding past a quiet platform at high speed. A bolt of lightning hits the front of the train, and at the same instant, another bolt hits the rear. An observer standing on the platform sees both flashes reach them at once and concludes that the strikes were simultaneous. But someone sitting at the midpoint inside the moving train is rushing toward one flash and away from the other. They see one light first, then the other, and deduce a different ordering. Neither observer is wrong. Each uses the rule that light travels at a fixed speed in a vacuum, and each judges simultaneity based on when the light from events reaches them. Special relativity insists that there is no privileged perspective. The platform and the train are both valid frames. What counts as at the same time becomes tangled with how you're moving. The universe doesn't provide a single master clock that everyone must consult. This isn't just about lightning and trains. Relativity of simultaneity means that distant slices of the universe can't all agree on a single global present. Your now on Earth includes some distant supernovae that have already exploded in your frame, while for another observer moving differently, those same explosions might still be part of the future. Both descriptions are consistent. The disagreement isn't about reality. It's about how space-time gets sliced into past, present, and future. Physicists visualize this with space-time diagrams, where each observer's notion of now is drawn as a slanted line rather than a straight, horizontal cut. Tilt the line, and different events move in or out of your present. Those simple sketches capture something profound. There is no single cosmic fabric labeled "this instant everywhere." Instead, there are many overlapping fabrics, each woven from the vantage point of a particular motion. In labs and observatories, this shows up as tiny but crucial corrections. When coordinating signals between fast-moving satellites and ground stations, engineers must account not only for time dilation, but also for how simultaneity shifts between frames. A ping sent at the same time as another action in one frame might not line up the same way in another. Software quietly reconciles these differences, ensuring data streams stay coherent. Behind smooth GPS positioning is a constant negotiation of what counts as now. For you, lying still in a room, these nuances never break the spell of your everyday present. You experience your life as a continuous thread, each new moment arriving in sequence, unquestioned. The brain likes a clean story. There was a before, there is a now, and there will be an after. The fact that someone moving differently might carve that story into different simultaneous slices never enters into your feelings about an upcoming day or a fading memory. If you imagine zooming far out to scales of galaxies and clusters, the idea gets even more delicate. Astronomers sometimes define a kind of cosmic time based on the average motion of matter in the universe, a standard of rest tied to the faint microwave background. In that frame, you can speak roughly of the universe being a certain age now, but tilt into another high-speed frame and those equal time slices warp. Even cosmic age is a bit frame-dependent. There's something quietly humbling in recognizing that your sense of a shared moment is local. The people in your city, your country, your hemisphere are close enough and slow enough relative to you that one practical now works well. But extend that intuition across light years, and it fractures. The universe does not convene a single global meeting where every star and galaxy checks in at once. Coordination dissolves with distance and speed. Emotionally, this can shift how you think about distance and connection. When you send a message, make a call, or remember someone far away, you might feel that you're briefly in the same moment, despite the miles. Physics quietly complicates the picture. Signals take time, clocks tick differently, simultaneity tilts, and yet, on human scales, those delays are small enough that your sense of shared time is functionally real. Reality leaves room for both the strictness of relativity and the softness of human experience. If the lack of a universal present feels disorienting, you're not alone. Many early thinkers found the idea deeply unsettling. It seems to steal something comforting, the notion that the universe moves forward together. But another way to see it is that reality is richer than a single timeline. There are many interwoven sequences, many valid ways to order events, all nested inside the same underlying structure. Your personal story is one such ordering, crafted from your particular path. You can imagine coastlines viewed from different angles. From one vantage point, two bays appear aligned. From another, one slips behind the headland. The land itself hasn't changed, only your perspective has. In a similar way, events in space-time retain their relationships, but judgments about at once depend on the angle from which you look. No single viewpoint owns the truth. Each reveals part of a larger, consistent pattern. Letting this sink in can paradoxically make you feel more anchored in your own experience. If there is no universal now to be late to or early for, then the pressure to sync perfectly with some imagined cosmic schedule eases. All you ever truly inhabit is your local present, the feel of fabric against your skin, the faint hum of electronics, the slow arc of your breath. That's where your version of time unfolds, regardless of what distant clocks and galaxies are doing. As that awareness settles, another layer of curiosity emerges. If where you are includes not only your position and motion, but also your gravitational environment, then the full story of time's behavior depends on all of these at once. Gravity, speed, and perspective combine to give each observer a slightly different experience of duration. The next step is to see how these ingredients come together over cosmic distances, where expanding space itself joins the conversation about how time passes. Far beyond the orbit of satellites and space stations, time gains another, quieter layer, the way it ties itself to the expansion of the universe. On very large scales, galaxies are not just drifting under local gravity, they're also being carried along by the stretching of space itself. That stretching gives cosmologists a way to define a kind of cosmic clock, a measure of how long it has been since the hot, dense beginning. Your life unfolds inside one particular reading on that vast dial. Astronomers sometimes speak of cosmic time, the age of the universe as measured by observers who move with the general flow of galaxies, not rushing especially fast in any direction. In that frame, the universe is about 13.8 billion years old. It's as if there were a natural rest frame, marked by the average motion of matter and the faint microwave background that bathes all of space. Against that backdrop, you can say roughly what era you live in. The cosmic microwave background itself works like an ancient photograph. It's the cooled remnant of the radiation that filled the universe when it was only about 380,000 years old, now stretched into microwaves by billions of years of expansion. When satellites such as COBE, WMAPIX and Planck mapped this glow, they weren't just making pretty skies, they were reading the universe's early clock. Tiny fluctuations in temperature told them how density and time were distributed shortly after the beginning. If you could hover in deep space, far from any galaxy, and tune a detector to that background, you'd hear a nearly uniform hiss with a temperature of about 2.7 degrees above absolute zero. Small variations in that temperature trace your motion. If you move in one direction, the radiation looks slightly hotter ahead and cooler behind. By adjusting your speed until the pattern becomes as symmetric as possible, you can define yourself as at rest with respect to the cosmic flow. There's something poetic about that. On human scales, rest means sitting still in a chair or standing on a sidewalk. On cosmic scales, rest means moving in such a way that the entire universe's leftover light looks balanced around you. Your where you are becomes not just a point in space, but a state of motion chosen to match the afterglow of the Big Bang. In that special state, your clock measures cosmic time as cleanly as possible. Of course, real galaxies, including the Milky Way, don't sit perfectly still in this frame. They jostle and swirl, pulled by neighboring clusters and filaments. Your home galaxy rushes through space at hundreds of kilometers per second relative to the microwave background. That motion adds its own small distortions to your experience of time, layered on top of gravity and expansion. Even the universe's preferred clock is only approximate when you zoom into local structures. Despite that, cosmologists can still speak meaningfully of epochs, times when radiation dominated, when matter took over, when dark energy began to rule the expansion. Each phase has its own flavor of time. In the early universe, everything changed quickly. Fractions of a second mattered, and conditions shifted violently. Today, evolution is slower on cosmic scales. Galaxies age over billions of years. Stars live and die. Dark energy steadily nudges the expansion faster. You inhabit a relatively quiet chapter. Thinking about that chapter can be strangely comforting. You were born into a universe that has cooled enough for atoms to form, for stars to build heavy elements, for planets to coalesce, for chemistry to experiment with life. You are not early in the story, when everything was too hot and dense, nor very late, when many lights may have gone out. You're somewhere in the middle pages, where complexity has enough time to bloom. Your personal minutes are nested inside that cosmic pacing. The measurements that reveal this didn't appear overnight. Generations of observers measured galaxy redshifts, built bigger telescopes, argued over the Hubble constant, refined distance ladders step by step. In offices cluttered with plots and printouts, they pushed error bars smaller and smaller, trying to pin down how fast space is stretching, and thus how old the universe is in cosmic time. Even today, small disagreements remain, a reminder that our grip on time's grand scale is still being adjusted. If you could somehow step outside your own lifespan and see your era as a point on the cosmic timeline, it would be a thin sliver in a very long bar. Yet from inside that sliver, your days feel full, sometimes even too crowded. The mismatch of scales is almost comical. Meetings and messages squeezed into a universe that measures itself in billions of years. Both perspectives are valid. One doesn't cancel the other. You might imagine a strip of film running from the Big Bang to some far future. Each frame a snapshot of the cosmos at a different age. Early frames are bright, blurry, dense. Middle frames show galaxies forming and clustering. Later frames dim as stars burn out. Somewhere in that sequence is the frame that corresponds to tonight, when you're lying here thinking about time. That frame is neither privileged nor trivial. It's simply the one your consciousness is currently sampling. On very large scales, then where you are includes what epoch you occupy. Time moves differently in a young, hot universe than in an old and expanded one, not because the equations change, but because the relative importance of matter, radiation, and dark energy shifts. The same underlying rules generate different behaviors as the contents of the universe rearrange. It's like listening to one piece of music at different points in its progression, same score, different mood. Realizing this can widen your sense of belonging. Your life isn't just pinned to a point on Earth's surface, or to a city or a room. It's pinned to a phase in the universe's history, to a particular reading on the cosmic clock. You're a creature of late-time expansion, of cooled spaces and mature galaxies. The way you think, feel, and organize your days happens against that specific backdrop. And once you start to see time that way, as something that depends on gravity, motion, and even the universe's age, another question starts to surface quietly beneath all the others. If the rules are so clear, why does your inner experience of time sometimes stretch and sometimes collapse, feeling long in one moment and vanishing in another, even when the physics around you barely changes at all? There's a different kind of time that never shows up in equations, and yet it governs most of what you actually feel. The time inside your head. A single minute can stretch painfully in a waiting room, while an hour with someone you love vanishes almost rudely. None of that has anything to do with gravitational wells or high-speed travel. The clocks on the wall keep ticking at their steady local rate. It's your perception that flexes, reshaping duration from the inside. Think about a day when you were anxious, refreshing a screen, watching for a notification that wouldn't appear. Each second seemed to linger, thick and sticky, refusing to move on. The same span of seconds counted by an atomic clock passed just as quickly as always, but attention kept looping back on itself, magnifying each moment's contents. The more closely you stare at time, the slower it feels, like watching individual frames instead of the whole film. Now remember a day that flashed by. Maybe you were traveling, meeting new people, or deeply absorbed in some project that swallowed your focus. When you looked up, it was suddenly evening. Again, the external duration was perfectly ordinary. What changed was how many checkpoints your mind laid down. How often you asked, and even subconsciously, how much time has passed. Immersion cuts those checks. Fewer markers mean the passage feels shorter in hindsight. Neuroscientists sometimes talk about time perception as a function of memory and attention. When your brain encodes more distinct events, later you interpret that stretch as longer. When fewer impressions are stored, the same clock interval feels compressed. This is why childhood summers seem endless in memory. New experiences fill them densely. Adult weeks, built from repeated routines, blur and seem shorter. The physics outside doesn't change. The density of remembered moments does. Inside a scanner or lab, researchers test this with tones, flashes, and simple tasks. Subjects are asked to judge which intervals felt longer, or to reproduce a duration by pressing a button. Patterns emerge. Fear and uncertainty lengthen perceived time, while calm focus shortens it. The amygdala, prefrontal regions, basal ganglia all get involved. These are not cosmic structures, just soft living tissue managing the rhythm of experience on a personal scale. Imagine lying in your bed right now as two clocks run. One is external, the device counting seconds as the video plays. The other is internal, a diffuse sense of how long you've been listening, colored by mood and tiredness. If your body is unwinding, each paragraph may slide by almost unnoticed. If your thoughts keep circling worries, you may feel every sentence land with more weight. Two times coexist, only loosely connected. The mismatch becomes most obvious in hindsight. A stressful year can feel like it took forever while you were inside it. Then later seems strangely short when you look back, because so many days blur into the same pattern. Conversely, a brief, intense period, travel, upheaval, learning something new, may feel short while it happens but long in memory, packed with distinct chapters. Your brain is constantly editing the story of how much time things took. On cosmic scales, relativity teaches that there is no single, universal now. On human scales, psychology adds that there is no single, objective, how long this felt. Your internal metric stretches and compresses durations, the way curved space-time stretches and compresses distances. The two layers don't contradict each other, they stack. You ride through a universe with flexible clocks while carrying a mind that rewrites those clocks subjectively. There's a quiet mercy in this. You have very little control over gravity or large-scale motion, but you can, at least a bit, influence how time feels. Shifting attention, changing environments, letting yourself enter deeper focus or deliberate rest, all of these can soften the sense of being chased by the clock. You may still have the same number of hours, but their texture becomes different, smoother, less abrasive against your thoughts. Even simple practices tap into this. Watching your breath for a few cycles, noticing the coolness of air in and the faint warmth on the way out, can briefly anchor you. For those moments, you're not repeatedly checking how much longer. You're just inhabiting each small slice as it comes. Time doesn't speed up or slow down in any physical sense, but the urge to measure it relaxes, and that alone changes the experience. Think of your day as a kind of personal space-time diagram, not of coordinates and velocities, but of attention and memory. Some sections are dense, others sparse. Some are jagged with interruptions, others smooth with continuity. At night, when you rewind mentally, you're not replaying an external clock. You're traversing this internal map. Parts with high emotional charge or novelty stand out like bright galaxies. Others recede into background noise. The idea that where you are shapes time now gains an entirely new dimension. It's no longer just altitude, gravity, or velocity. It's also mental state, emotional landscape, what surrounds you, and what you're focusing on. A noisy office and a quiet park can stretch the same hour in opposite ways. A tense conversation and a warm one leave different signatures in the memory of a single afternoon. And yet, for all this complexity, you don't have to manage time perception consciously all the time. You don't need to optimize every second. Sometimes it's enough to recognize that the feeling of no time or too much time is partly a construction. That recognition can put a little space between you and the urgency you feel, like stepping back from a painting to see the whole canvas instead of one harsh brushstroke. While you lie here, your internal clocks are still ticking. Metabolic cycles, neural rhythms, the oscillations that coordinate brain networks. They keep their quiet beat whether you're ruminating about tomorrow or drifting gently towards sleep. The physics of their timing is rooted in the same laws that govern orbiting planets and collapsing stars, but the story they tell you is much more intimate. They're keeping track of your private version of how long life feels. And once you've seen how physical and psychological time can diverge so gracefully, another question begins to form at the edge of your awareness. What happens to time when you move away from the familiar conditions of Earth altogether? Out to worlds with very different gravity, days, and skies, yet still carry the same human brain that insists on weaving its own rhythm through whatever the universe offers. On another world, even before relativity becomes dramatic, time would feel different simply because the rhythms are different. Picture standing on Mars, watching a pale, smaller sun move across a dusty sky. A Martian day, called a sol, is just a little longer than an Earth day, about 24 hours and 39 minutes. That small difference, repeated over and over, would slowly pull your inner clock out of sync with your old habits. You'd inhabit a day that refuses to match the one your body learned as home. Engineers and mission planners already deal with this. Teams running Mars rovers sometimes shift to Mars time, waking and sleeping according to the rover's local day. At first it feels novel, like jet lag turned into a science experiment. Weeks later, it becomes disorienting. Your schedule drifts relative to everyone around you on Earth. You're awake when others sleep, tired during their afternoons, floating between two time systems that never fully align. Imagine living permanently on a world where the day is much longer. Venus spins so slowly that a single Venusian day is longer than its year. On tidally locked exoplanets, one side may face the star forever while the other remains in perpetual night. Colonists on such worlds would have to invent artificial cycles, lights that mimic sunrise and sunset, schedules that bear no resemblance to the sky's behavior. Physical time would flow as always, but biological and social time would need careful choreography. Gravity, too, would quietly reshape your experience. On a super-Earth with heavier gravity, each step would feel more laborious, each movement slightly slower. Your heart would work harder, muscles fatigue sooner. Processes in your body might adapt over generations, but the first settlers would carry Earth-tuned expectations into a new well of space-time. Clocks would tick at a rate set by the local gravity. Hearts would find a matching beat E or struggle to. Stranger still would be life on a world orbiting close to a compact object, a white dwarf, neutron star, or even a black hole in some hypothetical future engineering feat. There, gravitational time dilation could grow large enough that centuries pass in the wider universe while only decades slip by on the surface. A settlement clinging to such a world would, in effect, live in a temporal eddy, their history compressed compared with the galaxies. Science fiction often plays with this idea, travelers spending a short time near a massive object and returning to find that everyone they knew has aged or vanished. The emotional core of those stories comes from genuine physics. Time really does run slower in deeper gravitational wells. A home built in such a place would be a kind of temporal island, its inhabitants drifting through a slower stream while the cosmic river races past. You can bring this thought experiment back to something quieter. Consider Earth's poles, where days and nights stretch into months, compared with equatorial regions where light and dark are more regular. People in these environments already report different feelings about seasons and years. Some speak of long, indistinct winters and brief, intense summers. Even modest changes in daylight patterns alter mood, memory, and the sense of how quickly a year has gone. Extend that intuition outward, and you begin to see how profoundly a planet's parameters sculpt its inhabitants' experience of time. Day length, year length, gravity, weather cycles, even the color of the star in the sky, all feed into the rhythms of sleep, work, celebration, and rest. A being raised under a red dwarf's dim glow on a world with 30-hour days would think your 24-hour Earth days and bright blue sky were the strange ones. Yet under all these variations, the same basic rules are at work. Clocks still depend on regular physical processes, vibrations of atoms, oscillations of crystals, cycles in circuits. General relativity still ties those processes to gravity and motion. Neurons still require time to fire. Hormones still pulse in slow rhythms. Memories still form across seconds and minutes. Different worlds would tune these rhythms differently, but the song's underlying structure would remain recognizable. If you imagine yourself visiting such a planet for a while, the first things you'd notice might be obvious. Heavier steps, longer days, perhaps a different color to the sunlight. After some time, subtler effects would emerge. Maybe conversations feel slower or faster. Maybe your sense of how long this task takes gradually shifts. Returning to Earth, you might find familiar durations strangely off, like hearing a song you love played half a beat too quickly. There's a quiet unity in this diversity. The universe allows an immense variety of environments, each with its own clockwork, but all following the same fundamental laws. A child counting 1, 2, 3 under a foreign star is using different units than UE, tied to a different sky. But the act of counting, of carving experience into ordered moments, is the same. Time, in that sense, is both local and universal. For you, though, tonight's where you are is simpler. You're on Earth, in one small region of one gravity well, under one particular sky that may or may not be visible from your window. Your body is attuned to this planet's rotation, this atmosphere, this level of light. Whatever strange worlds might exist elsewhere, you're currently synchronized with this one, and its familiar cycle of days and nights wraps gently around your routines. Letting your thoughts wander to other planets can create a kind of spaciousness. It reminds you that your schedule, your deadlines, your sense of being early or late are all written against a very specific and contingent backdrop. Change the planet and everything about timing changes with it. That realization can soften the edges of urgency. The universe has room for many different ways of living through time. Your way is just one. As that softness settles in your mind, another layer of curiosity begins to rise. If moving to another world can change your experience of time so deeply, what about moving to another scale, up to the galactic level, or down into the subatomic, where time can look almost frozen or wildly flickering, depending on which processes you choose to watch? If you shift your gaze from planets to entire galaxies, time begins to look almost motionless. A spiral galaxy can take hundreds of millions of years to complete a single rotation. Stars orbit its center so slowly that, on human timescales, they may as well be fixed points. If you camped on some dark plain and photographed the same patch of sky every night for your entire life, those grand structures would hardly change. Their story unfolds in frames too far apart for any one lifetime to string together. Astronomers compress those vast durations into short animations, stitching data from different epochs or simulations into videos where galaxies swirl like water spiraling down a drain. What took billions of years plays out in seconds. The trick works only because our minds are built to handle certain tempos. Anything much slower than a heartbeat, or much faster than a blink, needs to be sped up or slowed down before it feels real. On even larger scales, Clusters of galaxies drift through expanding space, pulled by each other's gravity and pushed apart by dark energy. Their motions are measured in kilometers per second, but the distances are so immense that positions barely change over centuries. To you, such structures are like mountains of time. They stand there, apparently eternal, while generations rise and fall in their faint light. Compared to them, a human life is closer to a spark than a candle. Now pivot to the opposite extreme. Inside your own body, countless processes are firing at speeds that make your fastest thoughts seem sluggish. Ions cross neuron membranes in fractions of milliseconds. Proteins fold in microseconds. Molecules collide, react and separate in time so brief you could never consciously track them. If you could slow them down enough to watch, they'd look like storms of motion, a restless churn of cause and effect packed into every second. Dive further into the realm of particles and time takes on an almost jittery quality. Some particles, like certain mesons, exist for trillionths of a second before decaying. Others, like the proton, appear so stable that their lifetimes stretch beyond the current age of the universe. At that scale, duration becomes a spectrum so wide that your intuitive sense of brief and long loses its grip completely. You need numbers written in powers of 10 just to keep track. Physicists tame this chaos with tools that can see extremely fast events. Ultra-fast lasers, particle detectors synchronized to unimaginably precise clocks. They talk about femtoseconds and attoseconds, quadrillionths and quintillionths of a second, as casually as you mention minutes. The fact that such intervals can be measured at all is one of the quiet triumphs of modern science. Your daily sense of time rides on top of a foundation that flickers at these astonishing speeds. Between those extremes, the near-frozen dance of galaxies and the frantic jitter of particles, your own scale sits in a narrow middle band. Heartbeats, footfalls, spoken sentences. The time it takes a kettle to boil or a page to be read all cluster around seconds to hours. Your entire nervous system and psychology are tuned to these ranges. Move too far away, and phenomena become abstract, needing translation to feel meaningful. You can think of it like a zoomable timeline. At one zoom level, you see the history of the universe, with billions of years squeezed into a meter of line. At another, your day fills the same distance. Zoom in further, and a single second stretches into a long path filled with molecular events. Each zoom level has its own sense of what counts as fast or slow, rare or constant. None of them are wrong. They're just perspectives. Where you choose to rest your attention on that timeline changes how time feels. Spending an evening thinking about the death of stars and the heat death of the universe can make your worries seem fleeting. Focusing instead on microsecond-level processes can make a single second feel almost impossibly rich. The same 60 minutes can be framed as barely a blink in cosmic terms, or as a universe of internal activity. There's a kind of relief in acknowledging that your natural sense of time is narrow and local. You weren't built to intuit the lifetime of a galaxy or the half-life of a subatomic particle. Those have to be learned, imagined, translated into metaphors you can carry in your mind. A galaxy rotation as a slowly turning wheel, a particle decay as a spark that barely appears before it's gone. This translation work is part of what makes science feel both humbling and beautiful. Even everyday technology relies on this layered structure. Your devices use crystals vibrating millions of times per second to keep time, transistors switching on and off in nanoseconds, signals traveling through circuits at a fraction of light speed. All that frantic activity is orchestrated so that, on your scale, things feel smooth. A video plays without stuttering. A song flows continuously. This voice reaches you at a comfortable pace. From another angle, You could say that where you are includes which slice of the timeline you choose to inhabit mentally. Tonight, you've been wandering up and down that ladder, from local clocks to satellites, from planets to galaxies, from neurons to particles. Your body hasn't moved much, but your attention has traveled across many orders of magnitude in time. Each shift subtly alters the emotional temperature of your thoughts. When you linger on slow, grand processes, life's rushes and deadlines can feel softer, like gusts of wind against a mountain. When you focus on the wild activity inside your own cells, a single breath begins to seem enormous, containing whole cascades of events. Neither perspective is obligatory. Both are available, depending on what kind of comfort or curiosity you need at a given moment. As this awareness sinks in, something gentle happens. Time becomes less of a single arrow and more of a layered fabric. The same seconds that carry your thoughts also cradle galactic drifts and quantum flickers. You're not outside those scales, you're nested between them, a mid-sized rhythm in a universe full of tempos. And once you've felt that nesting, that sense of being suspended between the almost frozen and the almost instantaneous, another more intimate question begins to rise. How does your own finite stretch of time, your personal lifespan, fit into this structure? And what does it mean to know that its pace and length are shaped by where and when in the universe you happen to exist? At some point, all these layers of time, the bending by gravity, the stretching by speed, the sprawling cosmic ages and twitching quantum instants, slide quietly into a different question. What does it mean that your time is so limited inside all this? You get a handful of decades, if things go well, in a universe that counts in billions of years. Your heart will beat a finite number of times. Your brain will only ever experience a narrow band of moments before it goes still. When you think about that too sharply, it can feel like standing at the edge of a cliff and looking down. The vastness below is not just space, but unlived time, eras you will never see, futures you won't visit, histories you missed by arriving when you did. The universe had a long, complicated life before you appeared, and it will continue its slow unfolding long after your own line in the diagram ends. Your personal relationship to time has its own gravity. There are periods that seem to pull everything inward, illness, grief, uncertainty, where days feel heavy and thick. Then there are lighter stretches, when time feels almost weightless, months fluttering past like pages in a thin book. None of this changes the external clock, but it changes how much of your finite span feels livable, how much of it registers as truly experienced rather than endured. If you trace your life on a mental timeline, you might mark childhood as a bright, sprawling region, full of firsts. Later years can seem compressed by comparison, even if they contain more calendar time. The brain allocates its attention unevenly across your history. Some scenes become anchor points, a particular afternoon, a certain conversation, a night under a specific sky, while others fade into a soft, undifferentiated background. Not all minutes are equally weighted in memory's sum. There's also the strange relativity between generations. A year is a much larger fraction of a child's life than of an elder's. For a 5-year-old, a year is 20% of everything they've ever known. For someone at 50, charmed, it's 2%. The same stretch of time sits differently in their minds. When older people say, "It goes faster every year," they're describing a kind of psychological time dilation. Each year shrinks compared to the total behind them. Where you are in your lifespan changes how you stand in relation to the universe's timeline. As a teenager or young adult, the future feels vast, lightly sketched, open. Midlife can bring a sense of narrowing, as options become choices and choices become commitments. Later, the awareness of finitude sharpens. You see more clearly that there are things you will not get to do, places you won't visit, versions of yourself you won't become. That realization can ache and clarify. Think for a moment about the older people in your life, or in your memory. Parents, grandparents, teachers, neighbors. They move through their own finite arcs of time, with their own mix of slow days and racing years. Many of them were born into a universe that, physically, was almost identical to the one you know now. Same age to a good approximation, same background radiation, same expanding fabric. Yet their inner sense of time, their stories about how fast it all went, are uniquely theirs. On dark nights, it's easy to feel small and late to the party, like you arrived after the universe's main events happened. The first stars, the first galaxies, the early shaping of cosmic structure. But from another angle, you're precisely on time. You exist in an era where complex chemistry, long-lived stars and stable planets make life like yours possible. You're late compared to the Big Bang, early compared to whatever long a dilute future waits ahead, but perfectly centered for your own existence. Still, the fact remains. There will be a last book you read, a last time you see a certain sky, a last conversation with each person you love. You rarely know when those lasts are happening. Time seldom announces its endings in real time. It lets you discover them backward. When you realize something hasn't happened again, that retroactive knowledge can give certain memories a quiet, bittersweet glow. Physics doesn't offer a loophole around this finitude. It suggests no hidden region where your personal timeline secretly extends. Instead, it gives you context. It shows you that the matter making up your body has already been part of other stories, stars, dust clouds, earlier worlds, and will go on to be part of future stories after your consciousness fades. Your limited stretch of awareness is one phase in a much longer journey of atoms. There's a kind of soft reconciliation in that view. You're not an isolated interruption in time. You're a temporary pattern assembled from ingredients that have been moving through the universe since its early days. Your particular way of experiencing seconds and years is unique, but the building blocks and the rules that govern them are shared with everything else. You're a local, fleeting reconfiguration of something very old. When you recognize that, the pressure to make every second count can shift. It doesn't have to mean filling every moment with productivity or significance. It can mean allowing yourself to simply be present for a reasonable number of moments, to inhabit your finite time with some gentleness. You will never see all the galaxies, solve all the mysteries, or live all the possible lives. But you can live this one attentively, within the slice you've been given. In a way, your finitude is part of what makes your time meaningful at all. An endless life might blur into sameness. Constraints give shape to value. Knowing that evenings like this are limited can make them feel more precious, not in an urgent, panicked way, but in the way a fragile object invites careful handling. You lie there listening, aware that there won't be infinite nights like this, and that awareness sharpens the quiet into something almost luminous. From the universe's vantage point, if it had one, your lifespan is a brief local fluctuation, a pattern that appears and dissolves. From your vantage point, the universe is the backdrop against which that brief pattern unfolds. Both views are compatible, even if they never meet. Time moves differently depending on where you are, and one of the most important wheres is simply this: inside a single mortal mind, awake for a while between two vast stretches of unknowing. And once you've looked at your own life through that lens, finite, context-dependent, nestled in a much larger flow, another, gentler curiosity emerges. If you can't change how long your time will be, is there a way to relate to it that feels less like being chased and more like being carried, more like floating in a current you can trust, at least for tonight? There's a quiet shift that happens when you stop treating time as an enemy and start seeing it as the medium you live in. Seconds are not bullets passing you by. They're more like the water a fish swims through, always there, unnoticed until you decide to pay attention. The universe, with all its bending and stretching of time, is not targeting you personally. It's simply offering a field in which your particular life can unfold. Think of how many conditions had to align for you to have any time at all. Stars needed to fuse heavier elements. Those elements had to disperse, gather into new clouds, form planets, cool, and allow chemistry to experiment. On one small world, life had to try countless configurations, slowly evolving the kind of nervous system capable of feeling bored, anxious, curious, or peaceful about the passage of time. Your worries about not enough are themselves a sign of an extraordinary sequence of events. On days when you feel rushed, it can help to remember that the universe is not keeping score of your productivity. The equations of relativity don't distinguish between hours spent in deep work and hours spent staring out a window. To them, both are just intervals along a world line. That doesn't mean your choices don't matter. It means the pressure to live up to some external cosmic timetable is an illusion. The only clocks that truly judge you are the ones you've internalized. You can picture setting some of those internal clocks down just for tonight. The ones that insist you're behind, that everyone else your age is farther along, that you're supposed to have reached certain milestones by now, those are like noisy, inaccurate wristwatches blinking different times. The universe itself offers no such judgments. It simply curves space-time, lets matter move, lets stars burn, and gives you the freedom to decide how gently or harshly you talk to yourself about your own pace. There's something soothing about aligning your sense of time more with physical reality and less with social comparison. Gravity doesn't rush, orbits don't hurry. Even light, as fast as it is, just goes at its speed, no faster, no slower, indifferent to any schedule. When you let some of that attitude seep in, your own minutes can start to feel less like a shrinking resource and more like a steady flow that you can sip from instead of gulping. Being aware that time moves differently depending on where you are doesn't have to be unsettling. It can be a reminder that you're always situated somewhere specific. In this room, in this gravity well, at this phase of life, in this emotional weather. You're not late for some universal present. You're exactly where you can be, given all the initial conditions that led here. Even your sense of being off schedule is part of the pattern. Consider how many kinds of time are layered into this moment. There's cosmic time, measuring billions of years since the early universe. There's geological time, recorded in rocks beneath you. There's biological time, ticking in your cells and heartbeat. There's psychological time, stretching or compressing your experience of this very sentence. All of those are intersecting right where you're lying. You are, in a very literal sense, a crossroads of timelines. Instead of trying to control all those layers, you can choose to cooperate with a few of them. Let your breathing slow to match the kind of rhythm your body prefers for rest. Let your thoughts adopt a slightly wider perspective, remembering that tonight's worries occupy only a tiny patch of your total lifespan and an unimaginably tiny patch of the universe's story. Cooperation with time feels different from fighting it. It feels more like floating than like running. When you think about your past, it's easy to focus on regrets, things you wish you'd done faster, started earlier, finished sooner. But the physics of your history is unchangeable. Those events sit where they sit in space-time, like stars fixed in a sky. What can shift is the way you relate to them. You can choose to see them not as failures to keep up, but as points on a path that brought you to a version of yourself who is, right now, capable of seeking understanding and calm. As for the future, it will arrive at 1 second per second no matter how you feel about it. You can't accelerate it by worrying, and you can't slow it by clinging. Plans and hopes still matter. They give structure to your limited time, but the underlying rate of flow is outside your jurisdiction. There's a certain relief in that. Some responsibilities really do belong to the universe rather than to you. The rotation of Earth, the expansion of space, the ages of stars, all handled. In that sense, your job becomes smaller and more manageable. You don't have to fix time. You only have to inhabit it. You don't need to understand every detail of relativity to go to sleep. You only need enough trust in the regularity of dawn to feel safe closing your eyes. The laws that govern satellites and black holes are the same ones that keep your bed on the floor and your lungs cycling air while you rest. They'll keep working while you're unconscious. There's also comfort in recognizing how shared your situation is. Every person you've ever met, admired or envied, has lived inside their own warped, stretched, finite slice of time shaped by where and when they were. No one gets the mythical, neutral timeline where everything is perfectly balanced and fair. Each of us navigates a personal version of where you are, with its own mixture of gravity, motion, culture, and inner weather. You're not failing by needing a rest inside yours. Look around your room. Even just in your mind's eye if the lights are off, the objects you see have their own small histories, manufactured, shipped, purchased, carried home. They've been slowly aging along with you, exposed to the same daytime and nighttime cycles, the same holidays, the same seasons. In their silent endurance, you can sense another reminder that time is something shared, not something you face alone. Everything in your environment is walking through it with you. As these ideas settle, your relationship to tonight can soften. You're no longer only the person trying to fall asleep before tomorrow's obligations. You're also a temporary observer in a universe where time flexes with gravity and speed, where clocks disagree, and yet reality remains coherent, where life found a way to exist in one gravity well at one cosmic epoch and wonder about all of this. That wondering itself is a gentle use of time. Soon, this particular stretch of awareness will fade into dreams or into the blankness of deep sleep. The universe will keep doing what it does, expanding a little more, rotating planets, letting stars burn. When you wake, the external clocks will have moved forward, and your internal clock will have edited tonight into however many fragments it decides to keep. For now, though, you don't have to manage any of that. You can simply let yourself be carried by the same quiet flow that carries galaxies, satellites, and heartbeats alike. Long before anyone worried about black holes or atomic clocks, time was simply the motion of the sky. People watched shadows shorten and lengthen, tracked the rising and setting of the sun, noticed the phases of the moon. Where you are meant latitude and season, and the local noon was just when the sun stood highest above your horizon. Every town had its own time, defined by its own sky. No one needed more precision than that to plant crops, light fires, and end the workday. Now picture yourself in an old village square centuries ago. The only clock is a bell in a stone tower, struck by hand or by a simple mechanism. When it rings, people look up from what they're doing, not because the seconds are precious, but because the sound gathers them into a shared rhythm. Market opening, prayer, rest. Time is still deeply tied to place. If you walked a few valleys away, the bell there might chime at slightly different moments. That gentle mismatch became a problem when trains entered the story. Railroads stitched far-flung towns together with tight schedules, and suddenly local noon in every city was chaos. Tickets, arrivals, and safety demanded a more rigid framework. So people began carving the planet into time zones, drawing lines on maps that told clocks what they should say. Where you are on Earth started to determine not just your sky, but an agreed-upon number on your watch. You can imagine a room full of officials and engineers in the 19th century, poring over charts, arguing about where to place those boundaries. The sun didn't draw them, humans did. Yet once adopted, time zones felt natural, almost obvious. Noon in one country, morning in another, night in a third, coordinated by longitude and politics rather than by each town's personal noon. Time became a global negotiation layered on top of the planet's rotation. Later, as technology demanded even more precision, humanity shifted to atomic time. Instead of watching shadows or stars, we began counting the vibrations of cesium atoms, billions of oscillations for each second. These clocks were so stable that tiny differences between Earth's rotation and the atomic definition of a day started to show. Leap seconds had to be added occasionally, so civil time wouldn't drift too far from the sun. Even the planet's spin, tugged by tides and quakes, proved imperfect as a metronome. Now there are multiple times running in parallel. There's UTC, the coordinated world time used by navigation and communication networks. There's GPS time, maintained by satellite constellations and drifting away from UTC unless corrected. There are local times in each country, sometimes shifted seasonally by daylight saving rules. Your phone quietly juggles all of this, matching its display to your current location, so your alarms and meetings make sense where you are. Think of all the invisible signals involved. Time codes ride on radio waves, fiber optic cables, satellite links. Around you, even as you lie still, your devices are listening to these rhythms, asking over and over, "What time is it now?" They adjust by milliseconds, smoothing out delays so that a call connects correctly, a live stream syncs, a payment goes through at the right instant. The infrastructure of modern life depends on a shared fiction of synchronized time, yet even that fiction fractures at the edges. Travelers crossing borders reset their watches. Some countries refuse daylight saving, others embrace it and then abandon it years later. A meeting that is 9 p.m. Thursday in one place is Friday very early somewhere else. Where you are on the planet can make you feel ahead or behind people you're talking to, as if you live slightly in their future or their past, even though the underlying physics doesn't privilege either. On screens, these differences become strangely intimate. You might watch a live broadcast from another continent, see comments scroll by in real time from people whose clocks say something completely different from yours. Good morning and good night appear side by side. The shared moment is real, yet everyone is embedded in a different local slice, framed by their own sky outside the window. Social time stretches across physical time like a net. When you schedule something, a call, a trip, even a reminder, you're quietly placing a marker on multiple timelines at once. There's your personal day, with its meals and routines. There's your local civil time. There's UTC in the background ticking through world servers. Somewhere, an atomic clock in a lab keeps count in vibrations. All of them conspire to make tomorrow at 10 mean something specific to you, here now. You rarely notice the layers. The more you think about these human-made systems, the more you see how contingent they are. A time zone could be redrawn. Daylight saving could be abolished. A leap second could be added or skipped. None of those decisions alter gravity or relativity, but they alter how your life lines up with the physical day-night cycle and with other people's schedules. Where you are in society shapes how your time is divided and named. And still, despite all these artificial structures, your body keeps its own quiet clock. Circadian rhythms drift toward roughly 24 hours, regardless of what governments decree. Jet lag is your biology refusing to immediately accept a new local time. It clings for a while to the old light-dark pattern. In that tug of war between social time and body time, you feel directly how where you are in the world can disagree with where your internal clocks believe you should be. If you zoom out from all this complexity, a soft truth emerges. The universe offers a continuous flow, marked by motion and change. On top of that, humans have layered grids, numbers, and names to coordinate their lives. Neither layer is wrong. The physical one keeps planets turning. The social one lets people meet, cooperate, and remember anniversaries. You inhabit both, the cosmic flow and the human schedule scribbled onto it. Lying here now, you're temporarily free from most of those schedules. Tomorrow's alarms and appointments belong to a future slice of your path. For the span of this listening, your main synchronization is simpler. Your heartbeat with your breath, your thoughts with the slow pace of this story. And somewhere underneath all of it, the same ancient truth holds steady. Time moves differently depending on where you are. And tonight, this is exactly where you are meant to be. If you let that idea settle like dust in a beam of light, another curiosity begins to glow softly. Beyond the clocks and zones and orbits, is there a way of relating to time that feels less like obeying a rigid schedule and more like listening to a piece of music, sometimes fast, sometimes slow, but always carrying you along in its own gentle, inevitable rhythm? When you think about your own life, you rarely picture a line of evenly spaced ticks marching from birth to now. Instead, you remember scenes, phases, turning points. Time becomes a story, with chapters and transitions, recurring themes and characters who enter and leave. Where you are slips from meaning a place on Earth to meaning a place in that unfolding narrative. Early, late, stuck, starting over, or quietly in the middle of a long arc you can't fully see yet. The brain seems built to weave time into stories. Isolated events are hard to carry. They need context. So you link moments into chains. This happened because... After that, I realized. From then on, I decided. Those links aren't always objectively accurate, but they give shape to the flow. They let you walk back and forth along your own timeline and feel that the person you were and the person you are belong to the same thread. Sometimes that thread feels tangled. There are choices you'd like to go back and edit, scenes you wish you could skip, whole stretches you'd rather not rewatch. Yet those very sections often explain why certain later parts of the story matter so much. A period of feeling lost can make a small success glow brighter. A long, slow recovery can turn an ordinary morning into something quietly triumphant. The emotional weight of time isn't evenly distributed. Memory edits the script constantly. Details blur, meanings shift. New information retroactively changes how you interpret old scenes. A conversation that once seemed trivial might later feel like the moment everything began to tilt. A day you thought was ordinary gains significance because of what came after. Your internal timeline is not a fixed record. It's a living document you keep rewriting as you move forward. Future time gets the same narrative treatment. You imagine yourself in years to come, filling in blank pages with guesses about relationships, work, health, and places you might live. Those imagined chapters are not predictions so much as sketches of desire and fear. They help you choose what to do next, which habits to cultivate, which risks to take, which paths to close. Your sense of where you are in life deeply depends on which future scenes you rehearse. In all of this, other people act like mirrors and anchors. A friend the same age may make you feel ahead, behind, or oddly parallel, depending on how their story compares to yours. Older relatives show you possible futures. Younger ones remind you of phases you've already passed. Time becomes relational, not just how long since or how long until by, but where am I relative to them? The comparisons can sting, but they can also soothe, reminding you that everyone is improvising. Consider how different your story would feel if you were dropped into another era. A medieval farmer, a future colonist on Mars, a sailor in the age of wooden ships, all would measure their lives with different milestones in different units. Lifespan, expectations, technologies, and dangers would all shift. Many of your current worries would be impossible. New ones would appear. That thought experiment shows how tightly your narrative of time is tied to the century and culture you inhabit. Even within your own era, your sense of time can change without the physics changing at all. A new job, a loss, a move to another city, a relationship ending or beginning, each can feel like stepping through a doorway into a new chapter. The weeks before and after are separated by a psychological boundary. You may even say things like, "That was another life," recognizing that the internal clock of meaning reset itself there. It's easy, in reflective moments, to judge earlier chapters harshly. You might cringe at past decisions or wish you'd used your time more wisely. But from the vantage point of those younger versions of you, the choices often made sense. They were working with a different map, different information, different emotional tools. Seeing that with compassion turns your timeline from a courtroom into an archive, less about verdicts, more about understanding how you became who you are. There's also the simple fact that you are always living at the cutting edge of your own story. No matter how much time has passed, you're perpetually at the newest page. That can feel intimidating, blank space ahead, but it also means you never run out of chances to relate differently to time. Even small shifts in how you spend an afternoon or how kindly you talk to yourself can alter the tone of the entire chapter you're in. From the universe's perspective, if it had one, your story is a tiny fluctuation in a sea of events. But from your perspective, it is the primary reality, the lens through which you encounter everything else, including ideas about relativity and cosmic history. Physics tells you how time behaves. Narrative tells you what that behavior means for a single human life. You need both, the outer explanation and the inner interpretation, to feel at home in the flow. When you think back on this particular night later, whether tomorrow or years from now, it may compress to a single impression: I couldn't sleep and listened to something about time. The hour will shrink in memory, folded into a larger pattern of nights. Yet while it's happening, this stretch has its own texture, specific thoughts, a certain heaviness of eyelids, the feel of fabric against your skin, the faint glow of a screen or darkness. It's a full little world. In that way, every moment is both tiny and complete. Each one is a point on a line and a universe of sensations in itself. You can't hold on to most of them. Memory will let almost all of them go. But they still exist as part of the continuous path you trace through space-time and through your own awareness. Their value doesn't depend on being remembered forever. Seen like this, time stops being just a resource you spend and becomes more like the canvas your story is painted on. The strokes may be messy, the composition may surprise you, but the mere fact that there is a painting at all, a finite one, with a beginning and an end, is already something rare in a universe where most matter never arranges itself into a self-aware narrative. As that realization settles, you may feel a subtle easing in your chest. The deadlines and regrets and comparisons don't vanish, but they take their place as small patterns on a much larger tapestry. You are living through one story among countless possible ones, at one pace among many possible tempos, under one sky among countless stars. And for tonight, that's enough. You're here. Time is moving as it must where you are, and you're allowed to simply drift with it for a while. You began tonight with a simple, unsettling question. Why does time move differently depending on where you are? Not just in the poetic sense of long days and short years, but in the literal, physical way the universe carves up duration. You've walked through gravity wells where clocks slow, ships that return younger than their twins, Galaxies that rotate so lazily they seem frozen, and particles whose entire lives fit inside a blink of your eye. The solid, uniform time you grew up imagining has quietly dissolved into something more flexible, more contextual, and strangely more beautiful. Along the way, you've watched clocks diverge just because one sits higher in a gravity field, or rides a fast orbit while another stays at home. You've seen how satellites must constantly reconcile these effects just to keep your navigation apps honest. You've looked at black holes and neutron stars not just as exotic objects, but as places where time itself bends into new shapes. It's as if the universe whispers, everywhere. What you call a second depends on where you stand. Then the focus folded inward, you traced how your own mind stretches and compresses time based on attention, emotion, and memory. Boring hours elongated, ecstatic ones vanished, dangerous minutes etched themselves deeply into recall. None of that changed the external ticking of atoms or circuits, yet it changed everything about how your life feels. Physical time eased into psychological time, and you saw that where you are also includes mood, stress level, presence, and the density of moments your mind chooses to keep. From there, your perspective widened and narrowed again and again. You visited other worlds with different gravities and day lengths, imagined settlements where sunrise and sunset had to be artificially manufactured, and felt how those parameters would sculpt entire cultures' sense of long and short. You rode the spectrum from galactic rotations to subatomic flickers, realizing that your natural perception occupies only a narrow middle band. Above and below it, reality hums along at tempos your intuition could never grasp without help. At some point, the question became personal. What does it mean for a finite human life to unfold inside such an elastic framework? You looked at your decades as a thin sliver on a cosmic timeline, and at the same time as a vast landscape when viewed from within. You felt the odd relativity between a child's year and an elder's year, the way entire chapters of your story later compress into a single sentence. That was the time when even your own past is subject to quiet re-editing. You also saw how much of your experience of time is invented, collectively. Time zones, calendars, working hours, daylight saving, all are agreements scribbled on top of Earth's rotation and orbit. Long before atomic clocks and GPS, people watched bells and shadows. Now devices align themselves with invisible signals from cesium atoms and satellites. Beneath all those layers of coordination and compromise, your body keeps its own rhythms, stubbornly loyal to light and darkness, sleep and waking, hunger and rest. By now, something may have softened in your relationship to time. It's harder to see it as a strict, unforgiving ruler, the same everywhere, judging how much you have or haven't done. It looks more like a landscape, varied and uneven, that you happen to be walking through at one particular altitude, speed, and emotional weather. Your task isn't to fix that landscape, it's to move through it with a little more gentleness toward yourself, knowing that the universe is not demanding any particular pace. As you lie here, all the layers we've talked about are still in play. Far above, satellites correct their clocks. Farther still, stars orbit the center of the galaxy. Deep inside you, ions cross membranes, molecules bump and react, neural rhythms sync and desync. Around all of it, expanding space slowly increases the distances between clusters, and in the very middle of that web sits something wonderfully ordinary. You, Iska, in a room, in this exact second, feeling the weight of blankets and the slow rise and fall of your breath. If you're still awake, and this calm kind of science has kept you company tonight, you're welcome to leave a small trace of your own moment in time. You could write in the comments where in the world you're listening from and what time it is there. There's something oddly comforting about knowing that the same story reaches different corners of the planet at different local hours, stitching together a quiet constellation of listeners under one stretching fabric of time. And if you'd like more nights like this, you can tap like and subscribe as a small way of saying, let's drift through more of these questions together. Very soon, this particular stretch of awareness will thin out. Maybe you'll remember fragments of it tomorrow. Maybe it will dissolve into the background of just another night. Either way, the laws that shaped everything you've heard, the relativity of clocks, the steadiness of cosmic expansion, the regularity of the Earth's spin, will keep working whether you're watching or not. You're allowed to set your thoughts down, let your attention loosen its grip, and trust that the universe will keep time without your supervision. For now, there is only this: a body growing heavier against the bed, a mind that has wandered from satellites to stars and back home again, and a quiet out invisible current of seconds carrying you forward. You don't need to count them. You don't need to use them perfectly. You can simply float for as long as you remain awake and then slide soundlessly into sleep. Another way of moving through time, where minutes and hours blur and the universe keeps watch while you rest.